Hello everyone. In this video, I'm going to talk about quadratic functions. What are they and their properties, the domain, range, and graph, their forms, and finally, I am going to do an exercise. So a quadratic function is basically a polynomial function whose degree is 2. In other words, it is a function that can be expressed as the form ax squared plus bx plus c with a not equal to 0, because if a is equal to 0, then it is not quadratic anymore. What is the graph of a quadratic function? It is called a parabola, and it's this U-shape. It is either a U-shape or an inverted U-shape. If it is a U-shape, then the lowest point is called the vertex of the parabola, and if it's an inverted U-shape, then the highest point will be the vertex in this case. A parabola also has an axis of symmetry which passes through its vertex. Now, how do we know whether the graph is a U-shape or an inverted U-shape? It all depends on the sign of A. If A is positive, then it is a U-shape, and the vertex is obviously a minimum. We say that the parabola is open upward or concave up. On the other hand, if A happens to be negative, then the vertex will be a maximum and the parabola is open downward, or we say that it's concave down. A quadratic function can be expressed in the general form, which is f of x equals to ax squared plus bx plus c, or the vertex form, which is a into x minus h to the power of 2 plus k, or some of them, not all the quadratic functions as you will see in a minute, can be expressed in the so-called factored form or intercept form, and this is how it looks like. If a quadratic function is expressed in the general form, then the vertex has coordinates minus b over 2a and f of minus b over 2a. The axis of symmetry has equation x equals to negative b over 2a. The domain is always all real numbers. What about the range? We have two cases. If a is positive, then the range is closed at f of negative b over 2a. And if a is negative, then the range will be negative infinity up to f of negative b over 2a. Let us do an example. Let us consider the quadratic function f of x equals to 2x squared plus x minus 1. Here a is equal to 2, b is equal to 1, and c is equal to negative 1. Thus, x of the vertex is equal to negative b, which is negative 1 over 2a, that is 2 times 2, and it is minus 1 over 4. What about the y of the vertex? It is f of what we got, so f of negative 1 over 4, and it is equal to negative 9 over 8. Thus, the vertex has coordinates negative 1 over 4 and negative 9 over 8. Moreover, since a is positive, then the vertex is a minimum. The domain of definition is always R, and the range is, since the vertex is a minimum, the range becomes f of negative b over 2a, which is negative 9 over 8, up to positive infinity. And finally, the axis of symmetry is x equals to negative b over 2a, which means x equals to negative 1 over 4. Let us now move on to the vertex form of a quadratic function, and it's f of x equals to a into x minus h squared plus k. And a is the same a as in the general form. This means, again, if a is positive, then the parabola is open up, and if a is negative, then the parabola is open down. What about the vertex? The vertex in this case has coordinates hk. The axis of symmetry has equation x equals to k, and again the range depends on a. If a is positive, then the range is k up to positive infinity, and if a is negative, then the range is negative infinity up to k. The third form of a quadratic function is called the factored form or the intercept form, and again, as I mentioned in the beginning, it is not always possible for any quadratic function to be expressed in this form. It is only possible if the parabola intersects the x-axis. Let us do some examples. Let us consider this parabola which intersects the x-axis at x equal to 1 and x equal to 3 over 2. This means that m is equal to 1 and n is equal to the other x-intercept, which is 3 over 2. So f of x becomes a into x minus 1 into x minus 3 over 2. What is left is to find a. How to do that? We choose any point on the parabola and plug it into the equation, so we get a. Now we have the point 0,3 is a point on the parabola. This means that f of 0 is equal to 3. So a multiplied by 0 minus 1 into 0 minus 3 over 2 is equal to 3, and this gives us a equals to 2. Therefore, this is the equation of the parabola, or you can simply expand it in order to convert it into the general form. So f of x equals 2x squared minus 5x plus 3. What if we have a parabola like this? Since there is no intersection with the x-axis, it is not possible to express it in the intercept form. The only two possible forms here are the general form and the vertex form. There is one more possible case, and it's when we have only one intercept. Here, it is possible to write it in the factored form where m and n are both equal to 5. So the parabola becomes f of x equals to a into x minus 5 into x minus 5, or simply x minus 5 to the power of 2. Again, how do we find a? We have f of 0 is equal to 25, and this gives us a equals to 1. Therefore, f of x is equal to x minus 5 to the power of 2, or if you want to express it in the general form, it is x squared minus 10x plus 25. There is one more thing I want to talk about in this video, and it's how to convert from the general form to the vertex form. Let us consider this example. F of x equals to 3x squared plus 14x minus 5. Step number 1, we always factor the a. So if a is not equal to 1, I have to take it out. This means f of x becomes 3 into x squared plus 14 over 3x minus 5 over 3. Step number 2, we have to complete the squares inside the parentheses. Thus, f of x is equal to 3 into x squared plus 14 over 3x. And before we copy the last term, which is negative 5 over 3, we have to complete the squares. We divide the coefficient of x by 2, so this becomes 14 over 3 over 2, and this is 7 over 3. Then, the answer that we got, we square it. So we add 7 over 3 squared and subtract the same number. The first three terms inside the parentheses form a perfect square. This term becomes negative 49 over 9, and we copy this term. Then we add these two fractions, and we get the following expression. Final step is to distribute the 3 again, and our quadratic function becomes the following expression. One last remark, to find h, we always convert the sign. So if it is plus, we put a minus, and vice versa. So h is equal to negative 7 over 3. However, the k is exactly the same number. So k is equal to negative 64 over 3. And of course, the vertex becomes minus 7 over 3 and negative 64 over 3. In the next video, I will do real-life applications on quadratic functions. Thank you for watching.